Today we're going to learn about the Pythagorean Theorem. So as we know, with a right triangle, it is a triangle that has one right angle, and there's a leg, and the hypotenuse is the longest side. So these sides can be represented with this Pythagorean Theorem equation, which says a squared plus b squared equals c squared. So it helps to name the sides of the angle, such as this. So the legs can go to either A or B. So if we flipped these two, it wouldn't make a difference, but we need to be sure that the hypotenuse remains as C. So we can plug the sides that we know into this equation in order to find the side of the unknown, and we can also use this concrete model in order to prove that this works. So let's begin with this triangle. So we have 4, so if we plug it into the equation, we have a squared plus b squared equals c squared. So I named this side A, so we have 4 squared plus this side B, which is 3 squared equals c squared. So if we solve it, we have 16 plus 9 equals c squared, which equals 25 equals c squared. And the square root of 25 equals c, and c equals 5. So we have it that this side equals 5. So let's see if it works. So if we have this 4 squared, so we have 4 times 4 equals 16. And we have this side, which is 3 squared, so 3 times 3 equals 9, should equal c squared. So if we see this, we have this b squared in the middle, and the a squared is distributed around this to equal 5 squared, which is our answer. So we can apply this to other models. So let's look at this one. So we can write in, again, a squared plus b squared equals c squared. And we can see how this equation works not only to find the hypotenuse, but to find the legs as well. So we're looking for a squared, so we're going to keep that as a variable. Plus b squared we know to be 4, so 4 squared equals 5 squared. So if we solve, we have a squared plus 16 equals 25, and 25 minus 16 is 9, and the square root of 9 is 3. So we can match it up again. So we have a squared plus b squared equals c squared. So it's the same as this one up here, but we can also use it to find the lengths of the legs. Now this also works because the answer is not always. So now looking at this problem, we have 6 as the legs, and we're trying to find the hypotenuse. So if we write out the equation, which we always need to do, and then we plug in 6 to the legs, so 6 squared plus 6 squared equals c squared. So we have 36 plus 36 equals c squared. Those added together equals 78 equals c squared. And we need to find the square root of 78. And that evens out to be approximately 8.2. So if we take 6 squared, so 6 times 6, and we take the other 6 squared, 6 times 6, add them together, should equal 8.2. So you can see we have 8, and then a little 0.2, and then same on this side, 8 and 0.2.